I'm actually going to just start with the talk and introduce myself a bit later. But basically, I worked for the Financial Times for 11 years. My last job there was tech director in charge of engineering enablement, which is basically platform engineering and developer experience and operations. I want to talk about effective software development. I want to start by asking you, how many people in this audience were working in software development 10 years ago? Okay, so I want to show you what the deployment process looked like at the Financial Times around a decade ago. And so we were releasing to production for the website 12 times a year, and actually that wasn't bad. We had code that would take about 4 weeks from when it was committed to when it went live. And there are still companies around today that are struggling to achieve that. But basically, very many steps in the process. And because the steps are manual, there's very little automation. It was slow, it was error-prone. There was an Excel spreadsheet with lines for each step for releasing. There were often typos in it. Because it took so long, we had to batch our stories together, which meant that you couldn't really tell what was having an impact. So if a metric improved after a release, which of the changes in that release made the difference? If it broke, what was the cause of the thing breaking? And you could spend quite a lot of time trying to work out which of the 100 changes that were in it had made the difference. And there are lots of handovers. There's handovers from developers into testers, they're from testers into operations. Because the structure that we had at the time looked like this. We had an infrastructure team that would buy servers and put them in our data center. We had development teams which would write. I was a developer at this point. You write code, you finish the code, you check it in, and then someone packages it up. The operations team deploys it and runs it in production. So there's a fair amount of waiting for other teams to do something. I'd finish work on a feature, and then maybe a month later, someone would call me up and say, we've had a problem with the release. Do you think you might have been behind it? And you've got to try and remember what you were doing a month ago. We needed DevOps. Because when you have separate people developing the code and running the code, you have a mismatch of incentives. Developers want to get the feature out. The ops team all know that releases are highly correlated with things going wrong. So you want to have those people working together. So they're aligning their approach. Operations teams start to do more coding. Developers start to care a bit more about production. At the time of that deployment process, I didn't write monitoring. That was done by somebody else after I'd packaged up the code. I wasn't building observability into my code. I'm pretty sure that the log messages that I had were very much of the got here, got here. They weren't things that would help you work out what was going on in production. But DevOps is not enough. You need to think about involving security in that. You need to think about involving testing in that. And it starts to get unwieldy, because what we actually need are autonomous cross-functional teams. All the skills necessary to build, deploy, and operate software. And autonomy to do that without needing sign-off from other teams. So you're not having to go to a meeting to say, I'm allowed to release this code next Thursday. That's the way it worked for me a decade ago. Evan Botcher wrote a blog post on Martin Fowler's blog about effective internal platforms. And he quotes research done by ThoughtWorks in Australia at a telecommunications company that showed that tasks that had to wait for another team took 10 to 12 times longer in elapsed time. That's a huge difference, just that waiting and having to coordinate. So removing that coupling has a high impact on productivity. There's quite a lot of other research that backs this up too. I'm hoping people are familiar with the DORA research. Who's familiar with that? Pretty much everyone. Yeah. So it's been running for 9 years. They've interviewed more than 36,000 people for it. Accelerate, was astonished to discover, came out in 2018. It documents quite a lot of the early findings. The research focuses on high performance as something that impacts your organization, that affects the productivity, profitability, and market share of you compared to your competitors. Recently went to have a look at the DORA site and saw that they've got a new proposal for their core model. The core model represents the most firmly established findings in their research. So what they're doing is that these are the things they've found through their surveys, that there are capabilities that are positively linked to performance and are linked to outcomes, both for the organization and for the teams. It is striking to me that there's really not very much here that's about architecture. There's nothing here about programming languages. There's nothing here about data stores. It's about how you deploy your code, your culture, and the processes. These are the things that make you successful as an organization. I just want to pick out two to talk about. Loosely coupled teams. Previous versions of DORA model talked about loosely coupled architectures. They've gone for talking about teams now. Conway's law says actually the two things are linked. You can't have a loosely coupled team without a loosely coupled architecture and vice versa. The teams are loosely coupled if they can work independently of other teams. This is about cross-functional teams. And the second one I want to pick out is empowering teams to choose tools. I think this is a surprise to me when I read Accelerate, that there's a positive correlation between letting teams choose their own tooling and success for that organization. So it's autonomy. It's autonomy in lots of respects. And, so DORA research says autonomy, supports autonomy. Autonomy is great. So you can release your code on demand. You can choose the right tools. It makes for happier teams. Drive has 3 motivations that Dan Pink identifies. Autonomy is one of them. The other 2 are mastery, which is the opportunity to improve your skills and learn things. I recognize that in software development teams. And purpose. Do you have a sense that you're working towards something worthwhile? So autonomy is fantastic, but you know what, so is standardization. And I say this as someone who ran operations at the FT. It's like, actually, the last thing you want when you have an incident in production is to discover that this team decided they were going to send their logs to a different log aggregation tool, and you don't have access to it. Standardization makes things less complex. There's less risk because you don't have to patch all of the various things that you have, lower cost potentially, and actually it makes things easier to move around. You can move services more easily if they're written in the same programming language. You can move people to tackle different problems if they're working in the same tech stack. So I spent over a decade working on the Financial Times. I left a little over 2 years ago. I spent a lot of time since writing a book about how to be successful with microservices. A lot of that for me draws on platform engineering and engineering enablement. The decade that I was at the FT, we went through a massive transformation. We went from those 12 releases a year to 20,000 releases a year. The trade-off between autonomy and standardization was a major theme. I want to talk about 3 things today. First, I'm going to tell you why I think paving the road is the answer to that trade-off. Then I want to talk about developing principles for how you go about building a platform, building a paved road. And then finally, what the mechanism should be when teams want to go off-road. Because I think you have to have something that defines when is it okay to do that? What do they have to do as part of doing that? But to start off, I will talk about why you need to pave the road. And to do that, I'm going to tell you more about the dark history of like a decade ago. So I joined the FT in 2011. We had a pretty small set of technology that we used. The systems were monolithic. They were written in Java. They were deployed to Tomcat. We had MySQL as the database. And as a reminder, that's how we were structured at the time. And if I try and think about a graph of autonomy against standardization, we had a very high degree of standardization and quite a low degree of autonomy. You couldn't make different architectural choices because you were operating within a monolith. It's a pretty standard approach. As a developer, I spent about 90% of my time writing code, which is great, but things didn't move fast. It was pretty frustrating. You didn't feel like you were achieving your goals. We wanted to make the pain go away. We wanted to be able to release more than 12 times a year. So we started to introduce automation and DevOps, started by automating provisioning and deployment pipelines. And then that led to changing the way we were set up, because now we could release code much more quickly. You really needed to have those DevOps teams. So we had cross-functional teams that built and operated their software, and we still had a platform team, and it was still a pretty mandatory platform. You did have some freedom to choose different data stores. You could make some choices, like we could start to develop more service-oriented architecture, start to do microservices. We saw increased autonomy. We had a decent amount of standardization, but there wasn't much room for innovation. That mandatory platform abstracted away a lot of complexity for us. One of the things it abstracted away was any access to the underlying AWS resources. So we couldn't, for example, decide to use a managed database. At this point, my team was basically installing databases on EC2 and running them, rather than just using the stuff that Amazon can provide to you. And the platform team at the time were not getting ahead of the alternatives. They were quite an old school platform team. We are going to build the platform, we will give it to you in a year's time. There was a lot of tension, and in the end, their teams started to move to alternatives, and then we move into what I like to call the period of an anarchic free-for-all. Autonomous teams doing their own thing. And they all made their own choices. So this is a subset of what we had in production at this point. So people had been writing in Java. There was still a lot of legacy code, but the back-end teams now decided to move to Go, largely. Our platform teams were using Python. Front-end teams were using Node. We had people running Kubernetes clusters. We used Heroku. We were using AWS, including serverless. Used loads of different data stores, and what I haven't even got on here is the number of different CI/CD approaches, the number of different ticketing systems. People decided they weren't going to use Jira, they were going to use Trello. There was nothing standard that you could rely on, really, basically. If you could have more than one thing of it, we did. Lots of autonomy, very little standardization. This is the point where I moved to take control of operations and just went, oh my God. So we ended up with an organizational structure that looks a bit like this. So all of these DevOps teams had gone and been really innovative and chosen lots of technology. And now they all had to have their own platform team. So you had to have a team that kind of did Kubernetes and one that did Heroku. And the underlying platform team still needed to exist because there were common things like CDNs, DNS. But if every product development team has to have their own mini platform team, they all solve the same problems. And although you can quite quickly get a piece of code through to production, actually, maybe you have 5 people in the team and 2 of them are wrestling with infrastructure. So you're not actually doing as much work as you might be doing. And there are other downsides as well, because with each technology that you add, you're adding cost and risk. And the FT do not want to be in the news for being hacked. They don't want to have a huge cloud bill because no one's got any control over it. And they want to be able to solve problems fast in production. And where you have every team doing their own thing, you're relying on every single one of those teams understanding what needs to be done to keep something secure, to manage costs. And that's tough. So in an attempt to mitigate that risk a bit, we came up with a set of guardrails, an engineering checklist that said, here's what we expect from you if you are buying technology and operating it. If you're not using things that are part of that core platform, here's what you need to do. So they covered the things we expected a team to consider to build the right thing and to build things right. We told every team, whatever they chose to do, they needed to comply with the guardrails. So they removed a bit of autonomy, they introduced a bit more standardization. What they also did was made it really clear to development teams that there's a lot of work involved in infrastructure and operations, work that had been done for them in the past by the platform team. And groups of developers could still make pretty diverse choices of languages and platforms. But, services get moved between teams all the time. You realize that actually this is not in the right domain, we should move it. It's a lot harder to move it when it was written in Go and this new team that are going to own it are Node developers. That's difficult. And moving people is hard, and I think that it's really good for organizations to be able to have people move around between different parts of the organization. It's really important for people as well. You learn a lot. But it's very difficult if that involves changing the programming language you use, the deployment stack that you use, everything about the ticketing system you use. It's a bit more daunting to think, well, think of myself as a Java developer, but now I'm a Node developer. And I have to learn a whole new thing. Some people want that challenge. Other times it's much harder to move people where they need to be. And going back to that idea of every team having their own mini platform team, it's not just about duplicating the effort to solve the problem. It's just about the breadth of stuff that you need to understand within that team. So cognitive load is about how much information you can hold in your head. And a team has a cognitive load as well. If if you have more information that you need to know than you can deal with, you're constantly context switching. You're trying to remember, what did I do the last time I did this 6 months ago? And really, you want your product engineering teams to be focused on the business problem that they're trying to solve, not trying to work out how they're going to fix this bug in the deployment pipeline. Product teams need help. So you need to remove that cognitive overload. You need to keep risk under control. You want them to hand off some of the work and abstract it away. That's where I like to turn to team topologies. I imagine you'll see a picture of team topologies on quite a few slides today. The aim is to have your product development teams, the yellow stream-aligned teams, really focused on delivering a stream of business value. And then you have other teams that are enabling them by being experts in a particular area or building platforms. And those platform teams, the platform group in blue, will collaborate closely with those teams to develop new services and then provide them as a service that other teams can use. The problem is, the more variable the tech stack is at that top there, the harder it is for those underlying platform teams to provide value to those users. If you've got 4 different programming languages, every single thing that they do has to have 4 versions of the library, and they have to have the expertise in all of those as well. Same with data stores. It makes it much harder. Same with continuous deployment pipelines. If you want to introduce security scanning or change and release logging into deployment pipelines, you've got to solve it 4 or 5 times if there's that number of different ways of deploying stuff to production. So the answer is to build a paved road, a golden path, which is basically an easy way to build, release, and operate software in a particular way, giving team autonomy where it matters the most, which is solving the business problems. It's the difference between walking along a path where you might turn your ankle and having tarmac. Paving the road is about building a set of options that work well together, that let teams move quickly. And you can go off-road, but it should be easier to walk along the paved part of it. I think it was Colin that mentioned this earlier. It shouldn't be mandatory, because there's a useful feedback mechanism if something isn't mandatory, that if it sucks, people won't use it. You find out that you're not providing value. If you're a team building a paved road, you should be able to build something that people want. Your customers are right there, and they're developers like you are. You should be able to work out what their problems are and help solve them. But that means you need to talk to your customers, which can be something that is a bit difficult for people. But that being not mandatory means you get that feedback. So paved road, for me, gives you a high degree of standardization, relatively high degree of autonomy. The standardization gives you a lot of security, cost control, and the autonomy lets teams do their own thing if it's valuable to the organization. And just to give you an idea of the kinds of things I'm talking about in a paved road, I ran the engineering enablement team at the FT. These are the things that we managed within that team. And I'm going to argue none of these are things that any product team should be excited about. It should just be done for them. And I would just like to say, I had to stop a product engineering at the FT team at the FT from creating a CI/CD pipeline out of lambdas because they were excited about how much better it was going to be than the existing ones. It's like, if it's 5% better and it took you a month, what else could you have been doing with that time? This is a fantastic blog post for anyone that hasn't yet started doing stuff. It's basically Charity Majors writes very well on a lot of things, but this is basically talking about the golden path and how you can approach deciding what you're going to make common across the organization. So I really recommend reading that. But I want to talk a bit about principles. So I think that it helps to develop a set of principles for why you would put something on the paved road and what it should look like, because it makes it easier to decide what you are going to do and what you're not going to do. We'll just start with the kind of obvious one, which is build what people need. And it is absolutely fascinating how, you really have to think about going and talking to people and listening to them. It's not enough to say to some team, hey, we've got this really great idea. We're going to build this service and we think it's going to be fantastic. And the developer says, yeah, that sounds good. That is not an enthusiastic, ringing endorsement. They're not necessarily going to use that. So You have to understand your customers. You have to go where they are. We sent out surveys. We would find we didn't get a hugely wide response. The same people would tend to reply to them. We might get 10%, might get 20% response rate. What we found was really useful was going to engineering meetings in other groups within the FT to listen to what they were complaining about. We said, could we come and listen? And you would sit there and they'd talk about their challenges, and you'd be able to say, that sounds like a thing we should fix. Or surprisingly often, that is a thing we have fixed, but you don't know about it, but we can now tell you. And I love Kathy Korovich's point to remember that you're a chef cooking for other chefs. So first of all, those developers are going to be critical of what you're building because they'll spot the inconsistencies, the anti-patterns, the hurdles, but they know the challenges, they understand the concerns. But the final point is, just because you like steak doesn't mean that everybody wants to eat steak. You start by making sure that something is valuable, solves a problem that people have better than the alternatives. And I think there's a danger, and Sam Newman wrote a fantastic blog post saying, don't call your team a platform team because they'll think they need to build a platform. You don't need to, as a platform engineering team, solve every problem yourself. You don't need to have every idea. Go out and look at what people have actually gone and solved within the organization, because there's this concept of a desire path, the idea that within a park, people will take the route that they want and gradually they'll wear a path. What you don't want to do is what's happened here, which is put a massive fence across it. What you should be doing is taking that path and paving it. So actually adopting what other teams have found and liked is a really good approach. So, for example, at the FT, Circle CI started being used by one of the product engineering teams. They liked it. Other people started using it. The platform team decided to make that available as a central thing because clearly people liked it. And in that case, mostly that involved just taking over the relationship with the vendor. It's a lot of what platform engineering teams do. But we in other cases, we took tools that people had written and we made them more generally usable by people in the rest of the organization. The next thing I think is really important. You want people to be confident in adopting the things that you use. In my early days at the FT, there was an attempt to build a platform which was called FT Cloud. There was some adoption, and then it got discontinued. But there were teams that were using it, and that's like, you do not want to get the reputation for getting rid of something and not providing an off-road. So you have to own the thing that you've built so that people can come and ask questions, and you need to have a plan for it. So you don't just go, it's not really supported anymore, it needs to be improved, it needs to be maintained, there needs to be a migration to something else. If you decide you're not going to do it, you have to look after the puppy. Don't make people wait. If an engineer has a task that they want to carry out, they want to make progress immediately. This is about maintaining that loose coupling between teams. So at the highest level, it's actually about discoverability. I think Jem mentioned it earlier. It's surprising how often someone builds a solution because they just don't know there is another solution. And we built a single hub at the FT to have every bit of documentation about common tools and services. So you could go there and know whether something existed, whether it was going to be created soon. And the aim was that engineers weren't going to go off and build something new because they just didn't know it was there. My colleague Reese created some marketing posters, O'Reilly covers, saying, you can go and find out about this thing in the tech hub. And that tech hub contained lots of documentation in a consistent way. We aimed to write something that could be used by our newest developers, juniors, new starters. So it's a technical reader, but doesn't have necessarily the context of the organization. We built a template for this to start making our documentation more just more consistent. And we also got a tech writer to come in and run workshops for the team to give people confidence that they knew how to write, technical documentation. This was fantastic. We have a lot of engineers from all over the place, lots of people not English as a first language. It really helped people to feel confident in writing documentation. And this is some documentation for Route 53 DNS. What's interesting is it's all about how do I get started? How do I get access? How do I use it? Because self-service is really important as a platform team. You don't want to be spending your time helping people when they could read something and just get on with it. And they don't want to be waiting for you either. Most of the time, people don't need help. Some of the time, they will. You can worry too much about building a solution for 100%, build the solution for the simple 80%, and for the rest of it say, come and talk to us. People are quite understanding if you say, you've got a complicated use case, because people actually quite like the idea that they're complicated and in some way special. So just say, normal people, the average person can use this stuff. Make things easy to use. So you want there to be APIs, documentation, and on-ramp. You want error messages to be consistent. You want everybody's experience to just be consistent throughout. I think engineers are really inventive, and you should expect people to extend and adapt the things you build. And we tried to take the Unix-style philosophy of lots of small components that you can connect together. So people could use part of the tool from the platform, integrate it into something they had built. If you do that, people will combine them in ways you didn't expect. So we always tried to have APIs. We tried to have libraries that you could use. One way we approached this was writing serverless blueprints. We had templates for using the serverless framework to build lambdas, to do simple things that happened a lot at the FT. You need to read something off a queue and stick it in S3. Here's a template for it. Now, templates have issues because basically once you've put them out there in the wild, people never come back and find the later version. But if you just want something that gets people started, that can be very effective. You want to help people do the right thing. People shouldn't have to go and read the guardrails. I have worked with engineers who will go and read guardrails start to finish. Even the people who do that aren't going to go back every month and check for changes. So you want to incorporate all of those things we're asking you to do into your tools so that people automatically do the right thing. So, for example, we wanted people to create runbooks, especially for our most critical systems. It was a guardrail to say, you need to write a runbook. So we made it really easy for people to see whether the information was up to scratch. So this is just a few of the fields. We scored the fields in the runbook. We combined it together. So we could say, here's it's 91% complete. And we gamified it a bit. We gathered together the services and the teams, and we put a dashboard to say, community is doing really well. And that led to things like this Slack message, which was another tech director telling me his team had now gone past my team in terms of the quality of the runbooks for about 10 minutes. So you want to build tools that stop people from making mistakes. Stop them from stepping on a rake. So that means making sure they're safe, the defaults are sensible, there's a small blast radius, they're secure. People can trust that your tools are not going to be the cause of them having some awful experience where they do something bad. We thought about reliability, thought about what was suitable levels of reliability for our tools so that any system that was using them wasn't going to be down because our tool was down. So I wanted to just give you the list of the 6 that I've talked about, but also wanted to say that I was really heartened to see the CNCF Platforms White Paper, which has the following key attributes for a platform. And there's a lot of overlap. And this is really worth reading this. And if Abby Bangser is around, if you want to talk to her, because she's on the group that wrote this white paper. Just want to talk a little bit about going off-road. I said the paved road shouldn't be mandatory. That means you need to define what happens when people want to go off that paved road. It should be quite rare, because it should be hard. You're going to have to hack through the undergrowth a bit. In general, you want people to save innovation for the stuff that's unique to you, the business differentiators. And there's a great article by Dan McKinley about choosing boring technology that says, well, you should think about innovation is something where you have a limited amount of space for it. You've got 3 innovation tokens. What are you going to use them for? I'm going to argue that as a product engineering team, you shouldn't be using them for your CI/CD pipeline. You shouldn't be using it for any of this stuff. But the main reason to go off-road is where a capability doesn't exist. Sometimes because the platform team hasn't built it yet. Sometimes because it just isn't needed by enough teams to do that. And I originally thought about saying can't be created in time. If it doesn't exist, I actually think you should let people go off-road, even if you as a platform team are thinking about doing this in the next quarter, because my experience is that plans change and you just end up with upset people who were relying on you finishing this and it slipped by a month and now they're just really annoyed. Let them go and build their own thing, and if it's good, you adopt it. If you build something else, you migrate them. That's fine. This is the more difficult thing for people who are running platform engineering teams, is that someone wants to go off the road because they don't like the thing you've built. They don't think it meets their requirements. It feels like criticism. It feels really personal. But it's important to realize that you can't build a capability that serves everyone's needs. And also, sometimes other teams are right. And they can be innovative in some of this area too. You just should accept that's something that could happen. But what you should do is define a lightweight process that means there's an opportunity to understand what's missing. You need to make sure there's a place to discuss tech changes with a wide impact, and that includes where people are going off the road. We had a thing called the Tech Governance Group, where you would create a relatively lightweight technology proposal that just said, here's my need, here's what I've considered, and give people a chance to comment on it. Maybe the platform team will say, that's a really good bit of feedback. So it's basically architecture decision records. And the discussion is the important thing. Documenting them is really useful. It's great to be able to go back and say, 3 years ago, what was I thinking? Because I really can't remember. Final point is that when people go off-road, they must comply with the guardrails. There's always a lot of pressure around, we just need to do this thing because we need to deliver this feature. If it goes into production, it's got to have logging, it's got to have observability, it's got to be secure. You might have a more lightweight try-out process where things don't quite go live, but you have to be really careful. So wrapping up, because I know I need to wrap up. Paving the road means you can find that balance between autonomy and standardization, and it lets product engineering teams focus on the most important things that they're doing. But organizations want developers to spend more time coding and less time thinking about and working on infrastructure. This is a fantastic roundup of developer experience information, which I highly recommend reading. And if you haven't got a picture of that, it's also quoted here. Why would a developer put up with a poor developer experience when they can find a job that better aligns with their needs and preferences? I think building an effective platform is a retention thing. And if you are ever struggling to explain to your leadership why you need to invest in things in platform engineering, talking about the cost of hiring new developers, all your developers got fed up and left to go somewhere that didn't suck, is quite a good thing to say. I have written a book. It's got quite a lot of stuff about platform engineering. It talks about paving the road, how to do governance and standardization, how to deal with upgrades and migrations, because that's a huge part of what you do as a platform engineering group. And it's difficult because no product engineering team thinks, oh, yeah, I'm so excited, I'm going to do a migration. And I have some copies, and I'll be signing them downstairs in lunchtime. Thank you.